Hello, Room 21 Rockstars, and welcome to the Oceans study video. Our test is coming up in a couple of days, and I am putting together a few things for you guys to kind of use at home to help you to get down all of the concepts that you might find on the Oceans assessment. So, whenever we have study videos, you're going to need a couple of things. You're just going to need a bunch of paper, okay, and something to write with. Okay, so I have a Sharpie today. You might have a pencil, pen, crayon, something. If you're doing this at home, you can write on the back of a box or anything, to be quite honest. Back of a pizza box, maybe something in the trash as long as it doesn't have things on. As long as you're writing on something, you're just going to need something to write a couple of notes down. So we're going to start from the beginning. If you have your science notebook here, we're just going to kind of go in order of how we learned the topics. And I think that it typically is much easier, guys, if you think back to the experiments that we did in class, because, those related directly to, honestly, everything that we, that you're going to see on the test. So we're going to go back to the very first day whenever everyone stood up and we tossed around the globe, and you had to tell me, did your thumb land on water or did it land on land? So what is the percentage of the Earth that is covered in water? It's pretty simple, right? It's 70% water, 30% land. Now I want to tie this into something that we just talked about in class today, and that would be where we get most of our oxygen from. Most people think we get most of our oxygen from the trees out in the forest, but we actually get it from the photoplankton in the ocean. And here's why. Because 70% of the globe is covered in water. So most of the oxygen that we breathe comes from the photoplankton, those little microscopic plants that I showed you guys today that live in the ocean. That's where most of our oxygen comes from. And of course, this 70% number is salt water. Okay, so think back to all those experiments that we did in class. The first thing that I want you to do is actually grab a sheet, and you can pause the video at any time in case you need to stop and reflect. You might have to rewind it. Just grab a blank sheet of paper, and I'd like you to pretend that you are a human. Okay, I just want you to kind of do an outline of the ocean floor. You guys did this in a number of ways. We have the diagram in your science notebook, we made our salt dome models, and you created your graph. Okay, so think back to all of those different things. What does the ocean floor look like? Draw your little person, because that's going to be real important. Here he is up on the beach. Okay, so he's building a sand castle, something like that. Okay, now, I'm going to name a part, and you are going to go ahead and put that name where it belongs. Are you guys ready? Okay, so part number one that I want you to think about, the continental slope. Go ahead and label the continental slope. Okay, don't worry about spelling right now. Just think about it. Go ahead and label, where do you think the continental slope is? Okay, the next part that I'd like you to label is the continental shelf. Continental shelf. Think back to the Google Earth image that I showed you, how it can actually be picked up from outer space, the continental shelf. So we have labeled the continental slope and the continental shelf. Now I want you to label the abyssal plain. And then go ahead and label the trench. Okay, hopefully you drew one. If you didn't, go ahead and sketch it in right now. And what else I would like you to do is actually to put a star, okay, put a star where it's going to be most shallow in the ocean, okay, on your diagram. So where is it most shallow? Meaning not much water, not very deep. Okay, let me see if I forgot anything else. Oh, before I forget, the seamounts. And you can also label, if you drew it, a volcano, okay, one that has punctured the water and come above. Okay, so now I'm going to show you my completed diagram, compare it, and see if you have everything that I have down. So here I have my person, okay, I have my continental shelf. I walk out. That is where you should actually have your star, right, guys? Because we know that the continental shelf is a shallow area, and this is actually the part, remember that light blue area that I showed you on Google Earth? That is where it is, most shallow. And then you have your continental slope. That's where it begins to drop off. It gets very, very deep. Then you have your flat area. That's the abyssal plain. Just think of the word plain, and it's, You guys know what plains are. And then we have our trenches, very deep. Seamounts, this is actually a volcano. And then your seamounts are your little volcanoes that are not yet up out of the water. Seamount is just an extra term. You really don't have to know it, guys, but it's kind of cool to know. And we'll be talking about it in a couple of weeks when we study earth layers and also rocks and minerals. Okay, so there's your diagram of Earth. That begins the first part of the review. Just make sure you look over that diagram. I honestly think you guys are solid with it, though, because you were so amazing in class with it that, you know, I don't know that you need to spend too much more time with it. Now, though, I do want to talk about a couple of things, and the first would be waves, currents, and tides, okay? Very important terms we've talked about in class. You made your diagram that you sorted out all the concepts. Just take a sheet of paper and make a three-way T-chart. Waves, tides, currents. You can just do WTC if you want to. And what I'm going to do is I'm going to name off a characteristic, and I would like you to put it under either waves, tides, or currents. Okay? Are you guys ready? Waves, tides, currents, three-way T-chart. Here we go. Okay, these are caused by the wind. So under that T-chart, let me just show you the first example that you could kind of go from. Here I have my T-chart. I'm just going to put wind under there. Put a bullet point and put wind. So I just want you to put the characteristics under whatever category they fall under. Okay. Second characteristic. There are 2 of these a day. We just talked about this today, right after the fire drill. Okay, the next one is, these are caused by the gravitational pull of the moon. Showed you guys an awesome video where the water was literally being kind of pulled out of the Earth's oceans. These could also be called underwater rivers. Think about this one. We did this in class. I want to see how you guys do with the next one. This involves a transfer of energy. Okay, no water is actually moved. Only a transfer of energy. Okay, let me think if I forgot anything. I think that's where I'm going to stop because I do want to talk about a few more things with currents in a second. But if you look at my diagram, under waves I have wind and I have transfer of energy. Remember, we do the wave in class. Nobody moved. Water doesn't actually move position in the ocean. Simply energy is being passed through the water, and it makes it appear as if the water is moving. Okay, so that would be waves. Tides, there are 2 of these a day, high and low tide. You know, my little guy who built his sandcastle, that sandcastle will be gone when high tide comes along because the moon has a little bit of gravity that's kind of pulling the Earth's oceans out of the ocean floor just a little bit, so the water rises. Okay, and then finally, currents. These are underwater rivers. Remember the Finding Nemo video with the turtles? Hey, dude, right? That would be the underwater rivers. Now, I do want to talk about currents just a little bit, only because we need to talk about the causes of currents, okay? That's very, very important that we have that down for our assessment and honestly just for life, okay? So we have currents. We know there are underwater rivers. I showed you that really awesome video of all of the currents of the world, okay, which was very important. If I have a map of the world here really quickly, and this is an awful map, so please just forgive me. The star is where we are, okay? Where is the Gulf Stream current? Okay, one of the most famous in the world. It has a big impact on our weather, like I showed you guys. Where is the Gulf Stream current? Just kind of point at the screen, think about it. Yeah, it goes right from the Gulf of Mexico, right here, up along Florida, right over to Europe, okay? It's a huge underwater river that's churning, and it brings us much of our warm weather that we receive from the Gulf of Mexico. So make sure you're able to locate the Gulf Stream current right about there, guys. Now, before we go on, I do want to talk about the causes of currents, okay? So think about our labs. Why would water just move under the surface so fast like an underwater river? Well, a couple of reasons, right? Number one would be the temperature difference, okay? So the water temp, and you may just want to write this down. I know it's in your notebook, but you may want to think about it a little bit more and really pause and, just kind of take it in. Okay, so we have the water temperatures. We know that when we go deeper in the ocean, what is the water temperature like? Yes, it's much colder. Okay, in fact, it's absolutely frigid. That's why we can't get down there. One of the reasons we can't get down there. And when it's at the surface, it's actually pretty warm because that's where the sun is hitting it. That's where most of the animals live, up at the surface. Okay, and when you have hot and cold come together, that's going to create some movement. Two other things would be density. Okay, the density of the water. Think about what we talked about with salt. Okay, as you go down in the ocean, guys, it's much more dense down at the bottom of the ocean, okay, because there's more salt in the water. The salt tends to go downward, okay, so that's something that's very important, that the density is on down, okay, so when you have more dense water down at the bottom of the ocean and less dense water at the top, it's floating kind of on top of that water like our egg. That is also going to cause those underwater oceans, underwater rivers to occur. And there's one final reason, and that would be wind. Okay, the wind and the waves actually do help the currents to move along. So currents are caused by water temperature, density, and wind. Those are all very, very important things to make sure we have down. Density goes along with salinity here, guys, because we know that there's more salt in the water at the bottom of the ocean versus the top. Okay, so here are the causes of currents. Really look at this. Remember how I talked about in class when the teacher says, this is really important? It's incredibly important. So you may want to pause the video, internalize it, get it down, tell it to somebody at home, tell it to your neighbor today in guided reading, anywhere that you are. Get this down. What are the causes of currents? Why do we have underwater rivers happening all through the world's oceans? Okay. Let me see what else we have going on here, guys. I have one other diagram I want us to look at. If this is the surface of the ocean, okay, and let me just draw a little boat. Okay, he's sailing along. Okay, obviously we know that we mapped our ocean floors because that boat sends off little pings of sound that go down, bounce back up, and they're able to figure out what the bottom of the ocean floor looks like. Now I have two arrows here, and I bet you guys know where I'm going. So as the depth of the ocean increases, meaning we go down, okay, so the depth, how deep it is, increases, we go down. Let's talk about a few major words, okay, that we want to kind of internalize. As we go down in the ocean, what happens to the temperature? Good, so the temp goes down, okay, and we have this diagram in our notebook, so you should have this down. So as the depth of the ocean increases, meaning the deepness increases, the temperature goes down, it becomes incredibly frigid. What happens to the salinity? The salinity goes up, okay? It is very salty at the bottom of the ocean. Remember, we talked about down here, it's literally, the water would be so incredibly clouded. It would almost be like a goop, okay? It's so salty because the water is more dense, okay? I'm trying to think of any other words. The word pressure. Think about the cup. What happens as the depth of the ocean increases, meaning as it goes deep, it increases. What happens to the pressure? The pressure increases. Remember, that's another reason why we cannot get, honestly, past this little section of the ocean, because we would be crushed. Okay, the pressure is absolutely so incredibly strong. Okay, so make sure you have those three words down. That'll help you with that. And I have two more things that I want us to look at, guys, and they would be the following, okay? First, when we conducted our experiment with the egg, or honestly, even when we built our ocean floors, we talked about the types of data, okay? Now, our song has it. We talked about it a couple weeks ago when we were doing all of those experiments in class. And remember, we have qualitative data, which is the senses, and quantitative data, which is numbers. And remember that N, quantity, numbers, N, numbers. So what I want you to do is think about the egg experiment. So the egg experiment, we had 2 cups of water. Okay, and your question was, how does salt affect an egg in water? So we had these 2 cups. One of the cups, okay, had salt, and I'm just going to put little dots to represent the salt. Okay. And then I'm actually going to draw an egg floating at the top. That is terrible, but you know, we're just trying to get this down. And the other cup was just fresh water, and there is an egg at the bottom. Okay, so what I want us to do right now is think about what were some qualitative data points that we had with this experiment, and what were some quantitative data points with this experiment, meaning things that dealt with numbers. So what were some qualitative dealing with the senses, and what were some quantitative data points dealing with numbers? Okay, so just go ahead, take a sheet of paper, write down qualitative, quantitative, think about it right now. Pause the screen if you need to spell them, and think about it. I'm going to do the same thing right now. Okay, now, I didn't write down everything I could think of, but here's what I came up with, guys. Under qualitative data, meaning just with the senses, what do you see, hear, smell, we're not tasting, or touching, that's your qualitative data. So we had clear water, obviously, with the fresh water, and it was more cloudy with the salt water. You could also say white eggs, things like that. Quantitative, meaning with numbers, we had 2 eggs. We put about 2 tablespoons of salt in the water, and we had 2 cups of water. So things dealing with numbers, okay? So make sure you get down qualitative senses, quantitative numbers, just like our song says, okay? Let me see if I have anything else. Honestly, the only other thing that I really want to talk to you guys about would include, honestly, what we talked about today with the food chain, okay, and the food web. The most important component, okay, the most important component to an ocean food web would be what? And I know half of you are going to say the sun. Yes, the sun is important, but the sun is not a living thing. What's the most important living organism? The most important living thing in the ocean? Yes, the phytoplankton, right? The photoplankton. They create, they produce the energy for the food web. And honestly, if you look at this representation, like we drew with the energy triangle, the sun powers everything, but the photoplankton are the largest at the bottom. And remember, I told you that it's kind of an energy triangle, and it deals with powers of 10 in our number system, because if you have 1,000 photoplankton, you really only can have 100 fish, you can only have 10 sharks, and you can only have 1 human. Because the minute that we disrupt this order, okay, if we had 1,000 sharks up here, they would all die because there would not be enough food for them. So it's the powers of 10. 1,000 divided by 10 is 100. 100 divided by 10 is 10. 10 divided by 10 is 1. And that's how it works. It goes right up. So just make sure you know that this guy right here, the photoplankton, is the most important organism in the ocean. And remember, I told you, even if you're a SpongeBob fan, plankton does not live on the bottom of the ocean. Why? Okay, that is a false representation in SpongeBob. It does not live in the bottom because it needs sunlight, and we know that sunlight only gets into the very tiny top layer of the ocean. So all of the photoplankton, and zooplankton for that matter, live at the very top of the ocean, and that is where most of our oxygen, as you know, comes from. Okay, guys, so that concludes our study video. Look over your notes, look over everything in your textbook, Volume 2, and also just watch this video again, or go back to a part in the video that there was a concept that was a little confusing for you, because I think that will really help you to be successful on this assessment. You know, I have our test right here in my hands. I'm not going to hold it up very long for you, but I know you're all going to rock it, but there are only 15 questions on our test, and honestly, there are no secrets, guys. Everything that we have learned in class is fair game for the test, and anything that we did learn in class we put into our notebook and is also available in this study video. So really put in some effective effort and some time to studying. If you're watching this today during guided reading, make sure you're focused and ready to rock and roll, or maybe during morning work, any of those times. I know that you guys are going to be awesome with your amazing effective effort. Just think about the number of neurons that you connected in your brain over the last 2 weeks. You guys have been awesome, absolutely awesome. Okay, so that concludes our ocean study video. I'll see you guys later, and with some effective effort, you're going to rock that.